You have this right here, and the rocket's going up, correct? There's your rocket. So you're saying that there's this right here. The camera's looking at it. You with me so far? Where's the elevation angle? Can someone tell me where the elevation angle is? Where's the elevation? Let's say this is point C, this is point R, and this is point L. Where's the elevation angle? Yes, Sarah. What? It's at C. This is the elevation angle. This question is asking you for how fast must the camera elevation angle change. So what do you know on this one? What do you know on this one? D what, D what? We'll call that H right there, the height. What do we know? You know dH dt is what? 880 feet per second. What do you want? Can someone tell me what you want? The rate of change of what that I've labeled there? The rate of change of what? What? Theta. You want d what, d what? D theta what? dt. Link theta and h together. That is absolutely correct. You want to link h and theta. What function can we use to link h and theta? And let's call this the base right here. There's b right here. Here's the base, and here's h. What function could we use to link together theta and h? There's a bunch of different ones we could choose. There's actually two I can think of. Yeah, go ahead.
Isn't there like the sine or cosine?
Sine. Which one do you want to use? Sine. The sine of theta is equal to what relationship is sine? Do you remember that SOHCAHTOA? Sine is what over what? Opposite over hypotenuse. What's the opposite of theta? What's opposite of theta? H. And we'll call this one, what's this? What do we want to call this one? Call that D right there? Sure. So it's going to be H over what? H over D. H over D. So what do we have what we know, we have what we want, and we have a relationship between the two. That's great. So you did it twice here. What did you do once you had the equation? What did you do once you had the link? You took the what? With respect to t. So we need to do the derivative with respect to t on this one right here. The derivative with respect to t. Try doing the derivative with respect to t right now. So what do you end up with on the left? You end up with cosine of theta times what? Times what? D theta over dt equals low d high minus high d low all over what? Low squared. So usually when I've written an equation, when we've done the derivative, I highlight what we want. What do we want here? What's the thing we want? We want d what? D theta dt. So we're going to have to find values for everything else. We have to find values for everything else to do this. We absolutely need to find values for everything else. So there's a few we know. Which ones do we know? It tells us a few of them. It knows dH dt. Where can we put dH dt? Well, that goes right there, correct? So we have dH dt. So we have that, right? Do we have anything else? I think we have something else. What else? We have h, right? Why? When the rocket ship is 4,000 feet high, so that right there, h is 4,000. So we have that one. Nice. Do we have anything else? Well, hold on. We know what b is, right? We know b is 3,000. Is b used anywhere in there? No, b isn't used anywhere in there, so okay. Which one could we find next?
D.
We could find d because we know that this is 3,000, right? We know this is 4,000, so what does d have to be if that's 3,000 and 4,000? Yeah, it's a nice triangle, right? So we have d, which is 5,000. So we have a bunch of these values. What's the one we need to find, though? What's h again? 4,000, right? Like this? So we have almost everything. What do we still need to find? Let me highlight it in blue here. We still need to find this, and we need to find... Oh, we have d still. There's another place d is, right? D is 5,000 right there. So we have to find theta and the rate of change of d. So which one do you want to do first? We actually did one of these yesterday. Which one did we do yesterday? The rate of change of d, right? And I think some of you found that by accident already.
Oh, is that what we found?
That's what you found, right? You found the rate of change of the distance. We need to do a different related rate question to do that, though. What is b squared plus h squared equal to? D squared. So if you take the derivative of that with respect to time, what do you get? 2b times db dt plus 2h times dh dt equals 2d times dd dt. It becomes hard to say. That's correct. We know a lot of those things because why are we doing this? Because we really want what? We want this right here, correct?
Yeah.
Can we fill in the blanks on some of this? Yes, we can. What's b equal to? 3,000. But what's dB dt? What's the rate of change of b?
0.
It's constant, right? It's 0 plus 2 times, what's h equal to? 4,000. Oh, what's dh dt? 880 equals 2 times, oh, what's d? We found that's 5,000 times dd dt. That's what we want, right? So what could you use right now to find that? What could you use? I'd allow you to use what right now? Can you tell me what, I think it's 70, what is it?
704.
So the dt comes out to be what? 704, absolutely. So where can we put that 704 now? We can put that 704 right there, which leaves us just one thing we need to find. What do we need to find? So to find cosine theta, what's the key to finding cosine theta right now? What do you have to find cosine theta? You need to find theta, right? You need to find theta. So it's when h is 4,000, b is 3,000. How do you find theta? How do you find theta if you have those three? You took pre-calc that in. Yeah, so let's plug everything in here. We now know that's 53.13. Oh, and I missed the parentheses, sorry. So what do we now know? 53.13 times d theta dt. Yeah? Go ahead. So what did I forget right there? The cosine. So if you're in degrees, it's going to be cosine of, that would be vastly wrong. Thank you. Times d theta dt is equal to what? 5,000. Did we find dh dt? Yeah, 5,000 times 880. Yep. Minus 4,000 times what? 704 all over. What is d? 5,000 squared. So you could just take this right here. You could take this right here and go whoop and put it right there. And now you have d theta dt. Do that on your calculator right.
I don't have it.
Okay. What do you got, Sarah?
Negative 65.872.
Negative 65.872? Really?
I didn't get that.
It shouldn't be negative. It's rising, right? So the angle should be going up, right?
Yeah, no, that's not-
Try it again. Make sure you're in degrees. Anybody have a different answer? Nasa, what do you have?
I got .106.
0.106?
I'm not in degrees.
Who got that? Who got that? Excellent. What's the measure on this? This is degrees per what? I think it's degrees per second.